electrochemical process, which an oxide layer is chemically built on the surface of a metal. Okay, so here we're going to discuss about three types of aluminium anodizing: hard anodized, porous anodized, and barrier anodized.
There are 5 purposes of aluminium anodizing. Number 1 is for hardening. Number 2 for corrosion and wear resistance. Number 3 is for color, which is for cosmetics application. And number 4 is for oxide layer that can act as insulator. And the last one is it can grow as aluminium oxide layer so that it can be dyed.
Hello guys, so here come why aluminium anodizing is important.
So the first one is to make a durable protective layer, and the second one is to hold lubricant in the pores. The third one is dyes for various application, and the fourth one is for decorative application.
Well, hello everyone. I would like to invite you to join me to see the mechanism and process of aluminium anodizing. Let's go!
The surface to be anodized is degreased to eliminate oils and greases deposited on the surfaces during previous processes. It is then rinsed with abundant water. After, an etching solution or chemical brightening is used to eliminate the natural oxide and make the surface appearance more uniform. The subsequent step is a rinse, followed by a neutralizing phase to eliminate the residues of the previous treatment solution. Further rinses are then performed to avoid contaminations due to carryover of the previous solutions into the subsequent phase and to obtain a clean surface. At this point, the surface is ready for the anodic oxidation phase that is carried out by immersing the aluminium piece in an electrolytic solution. The term anodic oxidation derives from the fact that the oxide layer forms on the pieces to be treated without depositing other metals or products on the surfaces, simply by placing the aluminium at the anode of the electrolytic tank. Anodizing is obtained by passing direct current through an electrolyte solution. In these conditions, the positive H ions and the negative OH ions of the electrolyte solution move toward the cathode and the anode respectively. After a few seconds of current flow through the electrolyte, oxygen develops at the anode that reacts with the aluminium, forming the aluminium oxide layer on its surface. The first layer of aluminium oxide is compact and continuous, making the subsequent passage of current difficult. This is called the barrier layer. Due to the continuous application of electrical current and the solvent action of the electrolyte solution, a series of attachment points begin to appear on the barrier layer, each corresponding to the origin of a pore of the anodic layer that is forming. Let's examine what occurs in these attachment points. Because they formed on the barrier layer before the oxide layer reached its maximum thickness, it becomes evident how the passage of electrical current was facilitated by the attachment points. The current is distributed in a radial manner with respect to the pore, which will have a semi-spherical shape, so that the various columns of oxide in formation assume at first a cylindrical form, in whose axis we will find the pore. Finally, due to the equidistance between the pores, these cylinders will transform into hexagonal prisms. At the end of the process, a layer of aluminium oxide is formed that is perfectly adherent and chemically bonded to the metal base. It is important to note that there is no kind of coating on aluminium or any other metal that has the same adherence as the anodic film that forms in the process of anodic oxidation. When the anodic layer is formed, another rinse cycle takes place to remove any possible residues of acids from the anodizing solution from the pores. At this point, there are two possibilities. If the natural color is requested, the coloring phase is skipped and you go directly to the subsequent rinsing and sealing phases. If, on the other hand, a coloring is requested, you go to a phase in which metallic salts or chemical compounds are deposited inside the pores of the anodic layer to produce various tonalities of light-resistant color. The most common processes of electrolytic and immersion coloring follow the directives of the Qualinod